Alright, what's up guys? In this video we're going to pick up with some multivariable calculus and we're going to talk about partial derivatives here. So Rad just has to find the indicated partial derivative. We want the partial with respect to x for x times e raised to the square root of x squared plus y squared. Okay, so partial derivatives is a very important concept that is essential to almost every multivariable calculus / vector calculus topic moving forward. So if you can't take partial derivatives, you won't be able to do really anything in Calc 3 in the more advanced chapters. So it's always a good idea to just practice taking some. Okay, so how do we take the partial derivative here? Well, first of all, we'll have to use the product rule. So let me first write that down. Hopefully you remember that from Calculus 1. That's the first rule that we know we're going to need. So let me write that down first. So hopefully you remember from Calculus 1, the product rule. Let's say I have two differentiable functions, f and g. Well, f times g prime, that's just going to be f prime times g plus f times g prime. So I want to get some extra paper. So that's the product rule. So the first thing we need to do is we need to establish what our first function is going to be and what our second function is going to be. So the first function is going to be x. The second function is e raised to the square root of x squared plus y squared. Now we already know what the partial with respect to x for x is. That's just 1, obviously. But now we need the partial with respect to x for e raised to the square root of x squared plus y squared. So to take the partial derivative there, we're going to have to use the chain rule. Now, since we're taking partial derivatives, we're going to have to rewrite the chain rule a little bit. So I'm going to rewrite it using partial derivatives, and since we let g be e raised to the square root of x squared plus y squared, that's what we'll use as the function notation for g. So for the chain rule, in terms of partial derivatives, it's going to be the partial of g with respect to x is going to be equal to the partial of g with respect to u multiplied by the partial of u with respect to x. Okay, so in our case, we know that the chain rule says, well, we'll have e to the u, okay? And then it says, well, we need to take the partial with respect to x of the square root of x squared plus y squared. So I need the partial with respect to x for the square root of x squared plus y squared. And what's crazy is we use the chain rule for that as well. So let's do that. How do we get the partial with respect to x for the square root of x squared plus y squared? Well, again, we use the chain rule. So we'll have 1 over 2 multiplied by the square root of x squared plus y squared. And then the chain rule says, well, we need to take the derivative of the what's under the radical here and multiply all of that by that. However, in this case, since we're taking partial derivatives, we're treating y as a constant, or it's fixed. So essentially, we would be multiplying by 2x. And what's going to end up happening is the 2's will cancel. The x can be multiplied straight across. And so therefore, we could say that the partial with respect to x for the square root of x squared plus y squared is just going to be x over the square root of x squared plus y squared. Okay. So now, the chain rule says, well, we'll have our e. We need to put the original u back in. So this is going to be e raised to the x squared plus y squared, because we leave the function alone, or put it back in this case, since we're writing out all the steps. And then we multiply by the partial with respect to x for the square root of x squared plus y squared, which we know was just x over the square root of x squared plus y squared. So you just get x raised to the square root of x squared plus y squared multiplied by x all over the square root of x squared plus y squared. and that's what you'll get. So when they ask us what is the partial with respect to x for e raised to the square root of x squared plus y squared, it's just going to be e raised to the square root of x squared plus y squared multiplied by x, all divided by the square root of x squared plus y squared. So we then just go back to the product rule and use it. So it's going to be f prime times g plus f times g prime. So that's just going to be 1 times e raised to the square root of x squared plus y squared plus x times e raised to the square root of x squared plus y squared multiplied by x, all divided by the square root of x squared plus y squared. And if you simplify, you can just write it as e raised to the square root of x squared plus y squared plus e raised to the square root of x squared plus y squared. Notice we got two x's here, so this would be x squared all over the square root of x squared plus y squared. And so when we do our partial derivative and take the use the product rule, we end up with the following answer for what we have. So we need our final answer, which we'll get here. Okay, so we need the partial with respect to x for x times e raised to the square root of x squared plus y squared. And our partial derivative here is just going to be e raised to the square root of x squared plus y squared plus raised to the square root of x squared plus y squared multiplied by x squared all over the square root of x squared plus y squared. And that is our partial derivative. All right, so if you guys have any questions about how I obtain my answer and my partial derivative, I'll be more than happy to talk through that with you. All right, guys, I'll see y'all next time. Y'all take care.